Hey all, how's it going? So in this one, I wanted to take a look at, we now have our prediction endpoint, but I want to take a look at the times that we're actually getting for it. So you can see here I have a 24-year-old and it's about 25 minutes, which I think is fine. But if we go in, change this to a 34-year-old, goes up by roughly a minute or so, which is still fine. Um, 34 is still pretty good age for that. And then as it goes up, it goes by 50 seconds in your 40s, and then once you get to 54, it goes up by like 1 second. So that's not the greatest distribution. And also, if you look at like what we're putting in for these, we're putting in to determine the outcome, we're putting in pull-ups and clean and jerk and snatch. These are a lot of strength-based movements. Whereas like in our database, we actually have times for their the best time for their 400, the best time for Fran, Grace, which are both very cardio intensive workouts. So I wanted to kind of improve the model accuracy so we can get a little bit more realistic times in there. So let's get into it. All right, so the first thing I want to do here is just get set up a little. So I have our makefile open in the root of our project. So that is the actual commands that we can run. So just for convenience sake, I want to add a new one. Because we're going to be calling the trainer file a lot, I just want to make a quick like convenience function for that. All right, so now I have some code here which can show the importance of our features. So we're taking all of our feature names and we're taking the actual importances when the model is actually trained. And then so that's going to return everything in ascending order. So we want to use the slicing syntax in Python. This colon -1, and that's going to basically reverse the whole thing for us. And then we just want to take everything in that sorted syntax, and we're doing a little bit of string formatting here to actually say, like, we want this as a percentage out to one decimal place to actually see what the importances are. So we'll save that and then see what we get. So if we use our makefile now and do make train, then it reports that pull-ups is 66.2% important in predicting a 5K, and that's obviously a little bit counterintuitive. So that kind of shows us that your feature selection does matter here. So without paying attention to the actual model yet, we can actually get a lot of bang for our buck by just selecting new features to actually input into this model. So if we scroll back up to the actual SQL query here, we should just be able to paste this. Yep. So now we're selecting their run 400 times, so how long it takes to do 400 meters, and how long they can do in the Fran, the Helen, the Grace, which are all, like I said earlier, they're all classic CrossFit workouts that involve running, so they'd obviously be good indicators. So likewise, we want to actually come down to where we're actually selecting the features, and now that we have a lot of other things in our data frame that we can use, we can just go ahead and paste that in. So this is basically the same list, just adding the other movements that we have. So notice that we're not including the run 5K in the feature list. And to illustrate that, I'll do that right now just so you can see. So if we include run 5K and then train from there, then run 5K is 100%. So the model is essentially going to cheat and say, oh, we have the run 5K time, so let's just use that rather than trying to predict. So we want to actually leave that out. So if we now run it, okay, you can see that the feature list, the Helen, which involves a fair amount of running, is included as the highest, and then the run 400, which is obviously also a very good indicator since that's a quarter mile, is the second most popular feature. Pull-ups are still up there, which is a little bit skewed, and age is down here, which is something that doesn't really make sense, but that's kind of the data that we have. So already, this model is a little more intuitive with feature selection. So what we can do to further improve this is with the limiting that we're doing, we can add the new features to that as well. So we're saying pull-ups between 10 and 50. We don't want anything out of there. And then we're doing a lot of limiting on this other stuff here. For height, this is in inches, so I'm saying 60 inches, which is what's that, 5 feet? Yeah, 5 feet, and then a little bit under 7 feet, I think, which is that should be about fine. And then run 50 between 50 seconds, which is a little under a minute, and under about a little over 3 minutes. So we're just limiting these to be like a little bit better data. So if we save that and then retrain this, we should see similar results here, I believe. Yeah, so about similar. The percentages changed a little bit. So Helen is still the top, then run 400. Fran, which is good. I expected that to be the third most feature. That is also a workout that involves a lot of running in it. That has moved up to third place now. Pull-ups are still pretty high up there. That could just be the data that we're getting. Age is still down here, which is kind of something that you don't necessarily expect, but that is kind of just the data that we have too. So now that we've gone ahead and we've retrained our model, that's not enough. So now that we have all these new features, not enough for our endpoint, I should say. Now that we have all these new features, we need a way for the user to actually be able to enter those, right? So if we go here to the routes file, so this contains the actual URL request that you're going to make. See, these are still just all the old features in here. So what I'm going to do, I have something on my clipboard. So come all the way down here and then Control V. So you can see kind of what changed here is I'm really just adding in the new features. Yeah, add that in docstring, that's fine, Copilot. And adding that to the actual predict 5K time, which is that method you can see here from hovering over it. It doesn't accept these new parameters yet, so we need to change that as well. So if we come up here to our predict.py file, we want to swap out this too. So if we come up to the function definition, and in VS Code, you can actually just collapse the whole thing and then highlight it and just hit paste if you have the new function on your keyboard. So, all right, so you can see now all of the new features are in here. So now if everything works correctly, we should be able to, we want to bring up the backend so that we have the actual endpoint ready to receive what we put in. And then if we come into Postman here, you can see the run 5K after. You can see I tried running this before I put in the routing changes here. And I get this message that X has 8 features. So blah, blah, blah. Basically, this means that the model is only expecting, or the model expects 13 features as input, but we are only passing in 8 features. So now that I changed up the route, this should work. Okay. So 1435 as a 34-year-old, so 25, 24, something like that. That's still okay. So I'm not expecting these to be magically different. 44 did go up by a fair amount. And then, yeah, 54, 64, those are still going to be kind of similar because we just don't have a lot of people in those age groups that we can draw off of. But if you go to 24 and 34 now, those are pretty similar numbers. And the gap from 34 to 44 is about what I'd expect. So that's one technique that we can use to kind of improve our model accuracy a little bit is the feature selection. And honestly, that's going to kind of give you the most bang for your buck here. What we'll do now is we'll look at the actual model itself and see if we can kind of improve that in the next video. So thanks for watching, and I'll see you in the next one.